Hello everybody, welcome to another video on Thomas's calculus. Today we are going to look at chapter 8.2, integration by parts. So here we use integration by parts when we have two functions fx and gx, but fx and gx are not related in any way. In other words, uh, uh, fx is not the derivative of gx or vice versa. Functions like x times cos x, that's when you use integration by parts, when x is not a derivative of cos x or cos x is not a derivative of x, or x squared to the power x squared times ex. So we'll do both these using integration by parts. Before we do that, let's go through some antiderivatives. So we know the antiderivative of x to the power n is 1 over n x to the power n plus 1. Sin x, antiderivative of sin x is 1 minus 1 over x cos x cos kx. Sin kx 1 over x. You'll have to remember this as well. Cos kx is 1 over k sin kx plus 6. This is the antiderivative. And this is important as well. And antiderivative, when you integrate 1 over x, you get ln x. So that's important as well. So once we know those, let's look at the following. Let's do a quick recap of derivatives. So we have two functions u, v, and we want to get the derivative of d derivative with respect to x. We know this is, when you differentiate it, it is dv over dx, we can say u dv over dx plus v du over dx. And we know we can integrate this. Let me use a different color to do that. If we integrate this, let's say in pink, dx, and we integrate this part, dx, integrate this part, dx, then we get from this, we get uv equals integral u dv plus integral v du. And if we take this to the other side, this part, we take it to the other side, we see uv minus integral v du is equal to integral u dv. And we'll rearrange the terms. So we get, if we write this term first, we get integral u dv equals uv minus integral v du. So we'll use this equation in the next formula. Say we want to integrate two functions. This is one function and this is another function of this nature. So we use the formula that we derived. We use this formula, integral u dv equals uv minus integral v du. That's the formula we use. So we have to decide what is going to be u and what is going to be dv. So here the simple rule would be to use x as u, so that when you differentiate it, when you differentiate x, the power reduces. You use a function like that as u, and the other function, the entire function, as dv. So we use the entire function, this function, as dv. So I'll show you why that is important. So if we use u equals x, then we know we differentiate it, du is equal to 1. Du over dx is equal to 1. So in other words, du is equal to dx. So that's 1. The next thing, we take the entire, the next part of it, and we say dv is equal to cos x dx. So now what we do is we integrate. We integrate this. When we integrate this, we get u equals sin x. So once we have u, we have, sorry, this is v, not u, sorry, v. We have v, we have u, and du. We can substitute them to this particular equation. So let's do that. So we know that uh, we equated this part to this equation. So that is equal to, let me start over again, integral x cos x dx is equal to u times v. We know u is x. We know u is x and v is sin x from here, and minus integral v du. V is sin x, du is dx. Now we know how to integrate this. So I will write this again because we don't have an x term here. So we have here x sin x, and integration of sin x is minus cos x. So we have plus cos x plus c. So all we did here was we took this function and divided that into two parts, u and dv. And all we had to do is find u, du, and v to substitute to this equation over here. Let me do another example. So let's look at the example x squared ex. Now here we want to take u as x squared. U equals x squared, because when you differentiate u, this reduces in power. So that is very useful here. So that's the function you should differentiate, and then we take the other part as dv. So we have dv equals e to the power x dx. So that's the part we use as dv. The rest of the part we use it as dv. So remember what we have, the equation we have to use, integral u dv equals uv minus integral v du. That's the equation we are going to use. So we differentiate this and we integrate this. So when you differentiate this, we get du over dx as 2x. So du is equal to 2x times dx. And now we integrate this, integrate that. When we integrate that, we get v equals e to the power x. So now we require u, du, and v to substitute it here to this equation. So this equation, I will use what we got here in this equation. So if u is equal to x squared and dv is equal to ex dx, u is equal to x squared ex, v is equal to ex minus integral uh, that is x v is equal to ex and du is equal to 2x ex dx. So we know that du is 2x ex. So now we have to integrate this part by parts again, but it is better than this because the power of x has reduced. So let's do this part again. Now it will be very careful. We're doing this part again. So here what we do is maybe I'll use a different color here. Let me use something like purple here. So we have u equals x and dv equals e to the power x dx. That's how we use that. So we know du over dx is equal to 1. So du is equal to dx. So at the moment we have u and we have du. We need v. So we integrate this, we get v equals e to the power x, and that's it. So once we have this here, now we substitute again to this equation again, right here. Then we have in integral, we don't have the 2 here, x is equal to x e x dx is equal to x e, uv. U is x, v is e to the power x minus integral e to the power x dx. That's v du. So now we know the integral of e to the power x. E to the power x is ex. So x ex minus ex plus c. That's the integration of this part. That part. So if you combine the two, you will have the complete integration of this entire function. So in other words, that function would be, I'll have to write this on a new slide. So I brought the most important parts from the previous slide to this part. So this slide. So we have x squared e to the power x minus this part. The answer for this part, I'll mark this part, is right here. So what we do here is, maybe I'll change colors again. So it will be, if we combine these two together, we will have x squared e to the power x minus 2 times, we write this part over here. Instead of this, we write this x to the power, maybe I should change color so that it will be clearer. We'll write that in purple, x e to the power x minus e to the power x, and we can just say c on the side. So that would be the answer for this equation. So you integrate, when you integrate a function like this with the power x to the power squared, you see at the second level the power reduces, and you can reuse integration by parts to get the integration of this value. Let me do another example. Let's say we have to solve this integral e to the power x cos x. Let me first write the equation u dv equals vu minus integral v du. So we need to find, we integrate by parts, and here we take ex as u and this part as dv. So let me work through this step by step. So if e to the power, let me write that in a different color. So if u is equal to e to the power x, du over dx is equal to e to the power x. We know the differentiation of e to the power x is e to the power x. So we know du is equal to e to the power x dx. Let me erase this part. So that's du over dx. Then we also write in a different color. I will write dv as cos x dx, and we know here that when we integrate this we get v equals sine x. Now we have u, sorry, we have u, we have du and v. So we can easily substitute it to this equation. So we know integral, it's u e to the power x cos x dx is equal to u times v. So u times v would be u is e to the power x and v is sine x minus, then we have e to the power x and du is sine x dx. So we have a similar function here. So now we'll have to do this function again. We'll have to differentiate that by parts. So let's do that next. So if you differentiate e to the power x sine x dx by parts by taking e to the power x as u equals e to the power x and dv equals sine dx, sine x dx. So if we differentiate this, we get du over dx is equal to e to the power x. Now this is the best part. You soon see when you integrate this, you get v equals minus cos x. Now you quickly see that this is similar to the function we started with over here. So now that we have, let me change the color again. Now that we have, maybe we should first write this du equals e to the power x dx. So now we have u, we have du, and we have v. So now we can substitute for this to this equation. Let me write it in a different color again. We will use blue. So we have we need here we need to substitute to u v minus integral v du. So u v here is minus e to the power x cos x minus integral. Again we have minus cos x e to the power x dx. So we see that this part, integration of this part is repeating itself. So let me take the next slide to show what we do next. So let me explain this once more. So this is the function we started with. Sorry, this is the function we started with, and we have seen that this function, this part is here, right here. So we'll combine the two functions and we'll write this again in a different color. So we have integral e to the power x cos x is equal to e to the power x sin x minus this value over here. So I'm going to copy that minus e to the power x cos x minus integral minus cos x e to the power x dx. Maybe I should write that again. Just a second. Erase that and write this here in small letters. So that would be integral minus cos x ex dx. This and this is the same thing. So this and this is the same function. So let me write that again. So integral e to the power x cos x dx is equal to e to the power x sin x minus e to the power x cos x minus e to the power x cos x dx. Now you might wonder, why is this negative? It's because negative and negative are right in a different color. Negative and negative is positive. That is true. But there's another negative here that made this a negative. So this negative belongs to the whole, the entire group. So this negative made this a negative, and though this is a positive, this was made a negative because of this negative over here. Okay, so this is positive, there's a bigger negative that has to be multiplied. So now we see there's e to the power x cos x dx integral e to the power x cos x dx. Now what we'll do here is it's kind of really neat. We combine these two together. So what we do is we bring this equation to the other side. So we have 2 integral e to the power x cos x dx is equal to e to the power x sin x minus e to the power x cos x. So then if you only want this function, of course plus c because we are integrating. So if you want only this function, we have integral e to the power x cos x dx is equal to e to the power x sin x minus. I just noticed I did a mistake here. So e to the power x, this should be minus cos x because this is v is equal to minus cos x. So it should be minus cos x. So if that is minus cos x, then this should be plus e to the power x because this minus and this minus makes it plus. And then I think I made a mistake here as well. So let me get rid of this. I think I'm going to redo this again, and so that you won't get confused. So this becomes, so e to the power x cos x is equal to all of these. So that is e to the power x sine x plus e to the power x cos x minus integral e to the power x cos x dx. So if I use another, let me use another slide to simplify that further. This is the equation we have. So we can, let me rewrite this, integral e to the power x cos x dx is equal to e to the power x sine x plus e to the power x cos x minus integral e to the power x cos x dx. If we bring this part to this side, we have twice that. So we have 2 integral e to the power x cos x dx is equal to e to the power x sine x plus e to the power x cos x plus c. So we can bring the 2 to the other side, divide the entire equation by 2, then we get e to the power x cos x dx is equal to e to the power x sine x plus e to the power x cos x divided by 2 plus c. So let me summarize this. In summary, so this was our original equation and we used this as our u and this as our dv, and then we got this was equal to e to the power x sine x minus e to the power x sine x. That's what we got dx. And then we again use the product rule where this was u and this was dv, and then we got minus e to the power minus e to the power x cos x integral minus cos x in x in x. That's what we got for this part. So it was equal to e to the power x sine x. Now, once we simplify this, we got e to the power x sine x plus e to the power x cos x minus this. So let me write this again. This and this gave a plus, but with this minus, it became a minus again. So that minus, we have integral e to the power x cos x dx. And the whole thing is equal to e to the power x cos x dx. So we bring this to this side, then we got 2 integral e to the power x cos x dx is equal to e to the power x sine x minus e to the power it's minus, so it's plus e to the power x cos x plus c. So then we said integral e to the power x cos x dx is equal to e to the power x sine x plus e to the power x cos x over 2 plus c. That's the answer. Let me do another example. The question is find the area of the region bounded by the curve e to y equals x e to the power minus x and the x-axis from 0 to 4. That's what they are asking for. Is let me change the color of this. What they're asking is from 0 to 4 x e minus x dx. That's what they're asking for. 0 to 4. So if we take this as u and this as dv, let me write the equation. I wrote the same equation here, and we want to convert it to this format over here. So it is u dv. So let's say here, let's take u as x, and we differentiate u. Du over dx is equal to 1. So du is equal to dx. And we take dv dv as dv as e to the power minus x dx. We integrate it, so we have v equals minus e to the power minus x. That's the integration. So if we now we have u, we have du, and we have v. So we substitute it to this equation. I'll change the color. So we substitute it to this equation. uh, all we get here. So we have 0 to 4 x e to the power minus x dx is equal to minus x e to the power minus x, and we integrate it from 0 to 4, and then we have minus integral minus e minus x dx, 0 to 4. Now here we do, so first we'll deal with the left side only. I'll use a different color for that. So we'll first do this part. So we write the equal sign here, giving us enough space. We first substitute x equals 4 for, for this. So we substitute x equals 4. Then we get minus 4 e to the power minus 4 minus, then we substitute 0. So it is minus 0 e to the power minus 0, close brackets, and we write this part as it is, but because minus minus is positive, we write it positive. 0 to 4 e to the power minus x dx. Okay, so we have here minus 4 e to the power minus 4, and then this is 0, so we have this part plus integral 0 to 4 e to the power minus x dx. We know how to integrate this. We don't need integration of parts. We can integrate this. So we have minus 4 e to the power minus 4, and integration of this is minus e to the power minus x from 0 to 4. So we have e to the power minus 4 e to the power minus 4 minus e to the power minus 4 minus e to the power minus 0. That's what we get. So if you use a calculator, you'll see it's 1 minus 5 e to the power minus 4 is approximate.